This is the EdExcel AS Level Maths Paper 1 from the sample papers. Question number 1. The line L passes through the points A with coordinates 3, 1 and B with coordinates 4, -2. We have to work out an equation for L. Now before we do anything else, we need to find out the gradient. We can find out the gradient using m equals y2 minus y1 over x2 minus x1. x1 is equal to 3, y1 is equal to 1, x2 is equal to 4, y2 is equal to -2. If I substitute these in to here, we have y2 take away y1, so we've got -2 take away 1, divided by x2, which is 4, minus x1, which is 3. You will find the gradient to equal -3. We can now find out the equation of the straight line by using y minus y1 equals m lots of x minus x1. So we have y minus y1, which is 1. This is equal to m, which is -3, lots of x minus x1, which is 3. And if we rearrange and simplify, we can conclude that the equation for the line L would be y equals -3x plus 10. Question number 2. A curve C has equation y equals 2x squared minus 12x plus 16. We have to find the gradient of the curve at the point P with coordinates 5, 6. Solutions based entirely on graphical or numerical methods are not acceptable. We need to find out the gradient. So, for us to do that, we need to find out the gradient function. We need to find out dy over dx. And if I differentiate 2x squared, I end up with 4x. And differentiate minus 12x, we end up with -12. And differentiating 16, we end up with 0. When x is equal to 5, we can find out the gradient of the curve at the point x equals 5. And so dy over dx, in this case, we have 4 lots of 5 minus 12, 20 minus 12, that's equal to 8. And so the gradient of the curve at the point P is 8. Question number 3. We're given that the point A has position vector 3i minus 7j, and the point B has position vector 8i plus 3j. We have to find the vector AB. For part A, for us to find the vector AB, we need to recognize the vector AB is equal to the vector OB minus OA. The vector OB is 8i plus 3j. The vector OA is 3i minus 7j. And so the vector AB, well, we have 8i minus 3i, that would be 5i, 3j minus 7j, that will be 10j. And now for part B of the question, we have to find the magnitude of the vector AB, give your answer as a simplified surd. For us to find the magnitude of the vector AB, we would have to use Pythagoras. we have 5 squared plus 10 squared square rooted, and if we work all of this out, we end up with 5 root 5. And so the magnitude of the vector AB is equal to 5 root 5. Question number 4. f of x is given as 4x cubed minus 12x squared plus 2x minus 6. We have to use the factor theorem to show that x minus 3 is a factor of f of x. Well, for us to show that x minus 3 is a factor of f of x, we begin by letting x minus 3 equal 0, which would imply that x is equal to 3. And if we substitute x equals 3 into f of x, we can see f of 3 is equal to 4 lots of 3 cubed minus 12 lots of 3 squared plus 2 lots of 3 minus 6. 27 times by 4 is 108. Minus 12 times by 9, that's minus 108. And then we have 6 minus the 6. The result of all this is equal to 0. And so we can conclude, as f of 3 is equal to 0, x minus 3 is a factor of f of x. Now, for part B of the question, hence show that 3 is the only real root of the equation f of x equals 0. Now, before we do anything else, we would have to factorize the cubic. We know x minus 3 is a factor, and if I multiply x minus 3 by some quadratic, say ax squared plus bx plus c, what I would get is the cubic 4x cubed minus 12x squared plus 2x minus 6. We can now compare coefficients to find the values of a, b and c. If I compare the x cubed terms, then you can see x times by ax squared gives an x cubed term, and on the right hand side I have 4 of them. So if I compare the x cubed, I have a equaling 4, from which we can conclude a is indeed equal to 4. If I compare the x squared terms, you can see on the left hand side we have x multiplied by bx gives an x squared term, and we also have the minus 3 multiplied by ax squared, which gives an x squared term. And on the right hand side we have minus 12 x squared. And so we have minus 3a plus b equals minus 12. I know what a is, that's 4. So I've got minus 3 lots of 4 plus b, which equals minus 12. Minus 12 plus b equals minus 12. B is equal to 0. And knowing that b equals 0, let's now compare the number terms. On the left hand side, I have minus 3 times by c of them, and on the right hand side I've got minus 6 of them. And so comparing the number terms, you can see we've got minus 3c equals minus 12, rather minus 3c equals minus 6, from which we can conclude c is equal to positive 2. Now, if we solve f of x equals 0, well, first of all, let's rewrite f of x. We have x minus 3 multiplied by ax squared, that would be 4x squared, plus bx, that will be plus 0x plus c, so we add on 2. And if I set this equal to 0, we have x minus 3 lots of 4x squared plus 2 equals 0. So x minus 3 is equal to 0, or 4x squared plus 2 equals 0. Now, if x minus 3 is equal to 0, this would imply x is equal to 3. And if I attempt to solve this, well, what we'll do over here is we'll use the discriminant. The discriminant will equal 0 squared minus 4 times by 4 multiplied by 2, which is negative 32, and as this is less than 0, we can therefore conclude from here x equals 3 is the only solution. Question number 5. We're given that f of x is equal to 2x plus 3 plus 12 over x squared, where x is greater than 0, and we have to show that the integral of f of x with respect to x in between 1 and 2 root 2 is 16 plus 3 root 2. What we will do to begin with is rewrite f of x. We will rewrite f of x as 2x plus 3 plus 12x to the power of minus 2. It makes the integration easier. And so if I were to integrate f of x in between 1 and 2 root 2, what I would have to do here is integrate this result here with respect to x. And so if we integrate this, integrating 2x, we end up with x squared. Integrating 3, we end up with 3x, and integrating 12x to the power of minus 2, we would end up with minus 12 x to the power of minus 1. And we will evaluate this in between 1 and 2 root 2. So for my upper limit, I've got 2 root 2 squared plus 3 lots of 2 root 2 minus 12 lots of 2 root 2 to the power of minus 1. And then I will subtract 1 squared plus 3 lots of 1 minus 12 lots of 1 to the power of minus 1. And so if I work all of this out, 2 root 2 all squared, that's just 8. And then we've got 3 lots of 2 root 2, so that's 6 root 2. And then we subtract minus 12 lots of 2 root 2 to the power of minus 1. And if you are uncomfortable with that, you can rewrite this as 12 over 2 root 2. And here we get 3 root 2. So I will subtract 3 root 2. That's for my upper bracket, and for my lower bracket, 1 plus 3 minus 12. That's minus 8. And so what we end up with here is 16 plus 3 root 2. Question number 6, we have to prove from first principles that the derivative of 3x squared is 6x. What we'll do to begin with is we will let f of x equal 3x squared. Now let's draw a quick diagram to help us out here. Here is part of the graph of y equals 3x squared. Now, when x is equal to x, the corresponding y value when x is equal to x is 3x squared. When x is equal to x plus h, the corresponding y value is 3 lots of x plus h squared. Now, to find the derivative, we take the limit as x tends towards 0 of f of x plus h minus f of x over h. And so f dash of x will equal the limit as x tends towards 0, rather as h tends towards 0 of, well, f of x plus h, that's 3 lots of x plus h squared. We then subtract f of x, which is 3x squared, and then we will divide this by h. So let's work all of this out. I have the limit as h tends towards 0 of 3 lots of x squared plus 2xh plus h squared minus 3x squared divided by h. So I've got the limit as h tends towards 0 of 3x squared plus 6xh plus 3h squared minus 3x squared divided by h, and if I divide as necessary, we've got the limit as h tends towards 0 of 3x squared minus 3x squared, that gives 0x squared. Then we've got 6xh divided by h, that's just going to be 6h, rather 6x, and 3h squared divided by h, that's going to be 3h. Now as h tends towards 0, the term here tends towards 0, so we are just left with 6x. Question number 7, for part A, we have to find the first 3 terms in ascending powers of x of the binomial expansion of 2 minus x over 2 to the power of 7, giving each term in its simplest form. Well, over here we have the formula for a binomial series. And so if we use this formula in ascending powers of x up to the x squared term, because we are only interested in the first three terms, you can see then for part A, 2 minus 1/2 x to the power of 7, that will equal, well, for the first term, we've got 7, choose 0, multiplied by 2 to the power of 7, lots of minus 1/2 x to the power of 0. The next term, we've got 7, choose 1, 2 to the power of 6, minus 1/2 x to the power of 1. And the term after this, we have 7, choose 2, 2 to the power of 5, lots of minus 1/2 x to the power of 2. And we continue with higher order terms. So if we work all of this out, we have 7, choose 0, lots of 2 to the power of 7, lots of minus 1/2 to the power of 0. The coefficient of x to the naught will be 128. For the next term, we have 7, choose 1, times 2 to the power of 6, times minus 0.5 to the power of 1. So the coefficient of x will be minus 224x. And for the next term, we've got 7, choose 2, 2 to the power of 5, minus 0.5 to the power of 2. It turns out we get 168 x squared, and we could continue with higher order terms. Now, for part B, we have to explain how you could use your expansion in part A to find an estimate to the value of 1.995 to the power of 7. Well, if we compare the 2 minus x over 2 with the 1.995, both of them are being raised to the power of 7, which makes the comparison quite easy. And so for part B, we've got 2 minus 1/2 x to the power of 7 equaling 1.995 to the power of 7. And if I solve for x, we've got 1.995 take away 2 divided by minus 1/2. It turns out x would equal 0.01. And the idea is we will substitute this x equals 0.01 back into the expansion. So we substitute x equals 0.01 back into this expansion here. Question number 8. A triangle alone is modelled by the triangle ABC, as we see in figure 1. The length AB is to be 30 meters long. We're given the angle BAC is 70 degrees and the angle ABC is 60 degrees. We have to calculate the area of the lawn to 3 significant figures. Well, for us to calculate the area, what we need is 2 sides and an angle in between them. Now we've got an angle here, we've got a length here, and we've got an angle here. Let's somehow calculate this side here. How could we do that? Well, I'd have to use the sine rule, but for me to use the sine rule, I need the angle here. And so the angle ACB will equal 180 minus 70 minus 60, which is 50. We've got 50 degrees. The 50 degrees would go here. And so if we were to use the sine rule, we have CB over the sine of 70 equals 30 over the sine of 50, and therefore CB will equal 30 sine 70 divided by sine 50. So if we work all of this out, 30 sine 70 divided by sine 50, we get 36.8 etc. meters. So let's add this to the diagram. We have 36.8 etc. meters. And now we can use a half AB sine C to calculate the area. And so the area here would equal 1/2 times by 36.8 etc. times by 30 times by, well, we've got the sine of 60, we've got this side and this side, which are in between the angle 60 degrees. And so we multiply this by the sine of 60, so I've got 1/2 times by 30 times by the value here I've just calculated times by the sine of 60. It turns out the area is equal to 478.05 etc. to 3 significant figures. We've got 478 meters squared. And now for part B, we have to explain why our answer is unlikely to be accurate to the nearest square meter. So for part B, we require our answer to be rounded to at least 4 significant figures. That's why it can't be to the nearest square meter, and in reality the lawn may not be completely flat or triangular. Question number 9, we have to solve for x being in between 360 and 540, the equation 12 sine squared x plus 7 cos x minus 13 equals 0, giving our answer to 1 decimal place. To begin with, we know already that sine squared theta plus cos squared theta is equivalent to 1, from which we can conclude that sine squared is equal to 1 minus cos squared. And the reason I want to rearrange for sine squared is because if I replace this sine squared with 1 minus cos squared, I'd have an equation involving cosines only. And so replacing as necessary, we've got 12 sine squared. Now the sine squared is the same as 1 minus cos squared. And then we've got plus 7 cos x minus 13. This is all equal to 0. And if I expand out, we end up with 12 minus 12 cos squared x plus 7 cos x minus 13 equals 0. And if I simplify all this equation, we end up with 12 cos squared x minus 7 cos x plus 1 equals 0. And if I attempt to factorize, we have 3 cos x minus 1 multiplied by 4 cos x minus 1 equaling 0, from which we can see cos x is either equal to 1/3 or 1/4. Now, there are many ways of solving this, but what we can do is find out our initial two values and then add on repeats of 360. So, doing so, if I take the inverse cosine of 1/3, my first value is 70.528, etc. My next value, well, let's store this into my value of a. My next value will be 360 minus this, which is 289.471, etc. Let's store this into b. And then what we're going to do is add on our repeats of 360. So if I take my value of a and then add on 360, it turns out my next value will be 430.528, etc. And if I take my value of b and add 360 to it, I get something which is outside the required interval between 360 and 540. And so what we have here is one of the values we require. Let's work out the other values. If I do the inverse cosine of 1/4, I get 75.522. Let's just move the calculator here. So I've got another value of 75.522, etc. And if I store this into a, and if I do 360 minus this, I get 284.477, etc. And if I add 360 to this, I get something larger than 540. So if I take my new value of a and then add on the repeat of 360, I get 435.522, etc. This here is a second value I require. And so in the required interval, we've got x equals, to one decimal place, 430.5 degrees, and we also have 435.5 degrees, of course, to one decimal place. Question number 10. The equation kx squared plus 4kx plus 3 equals 0, where k is a constant, has no real roots, and we have to prove that 0 is less than or equal to k, which is less than 3/4. We need to use the discriminant, and that's suggested by the phrase no real roots. So for the discriminant, first of all, you can see a is equal to k, b is equal to 4k, and c is equal to 3. And if we use the discriminant, we have b squared minus 4ac being less than 0. And the reason it's less than 0 is because we've got no real roots. And using the discriminant, we've got b squared, so that would be 4k squared minus 4a c. This is less than 0. 16k squared minus 12k is less than 0. if I factorise out of 4k, we've got 4k lots of 4k minus 3 being less than 0. And so our critical values, we've got k equaling 0 and k equaling 3. And if I attempt to solve the inequality, because it's less than 0, we've got 0, which is less than or equal to k, which is less than 3 over 4. But we need to be careful here. We want no real roots. Now what happens when k is equal to 0? Well, when k equals 0, substituting this back into the original equation, we've got 0 x squared plus 4 lots of 0 times by x plus 3 equals 0. In other words, 3 equals 0, which is a contradiction. So in other words, for us to have no real roots, k must also equal 0. And so our solution to the inequality will be 0 being less than or equal to k being less than 3 over 4. Question number 11 for part A, we have to prove that for all positive values of x and y, the square root of xy is less than or equal to x plus y over 2. Now this is difficult to understand, but the idea here is we will work backwards and then we'd have some place to start off. So if I start off with xy square rooted being less than or equal to x plus y over 2, let's rearrange. Well, if I multiply by 2, I've got 2, and then the square root of xy I can rewrite as square root x times by square root y, and this is less than or equal to x plus y. And if I take everything over on one side, we've got x minus 2 times by square root x times square root y plus y is greater or equal than 0. We've got a perfect square here. We have we have square root x minus square root y multiplied by square root x minus square root y, which is the same as square root x minus square root y squared. The line here is our starting point. We will start here and work backwards to get to this stage here. And the reason this will work is because each line is equivalent. So what we'll do to begin with is start off with the line square root x minus square root y all squared. We're going to start off with this line and then work backwards. Square root x minus square root y all squared is the same as square root x minus square root y multiplied by square root x minus square root y. Square root x times square root x is x. Square root x times minus square root y twice will be minus 2 lots of square root x times by square root y, and minus square root y times minus square root y, that will be positive y. And just forgot to add on, this is all greater or equal to 0. And so we want to get to this line to here. Now, if I write this line out, which I can get from here, I can see that 2 times square root x times square root y is less than or equal to x plus y, and if I divide both sides by 2, I have square root x times square root y being less than or equal to x plus y over 2. Now, square root x times square root y is the same as the square root of xy. So I've got square root of xy being less than or equal to x plus y over 2, and this is exactly what I wanted to show. So let's write down that line, hence shown. And now for part B, we have to prove by a means of counterexample that this is not true when x and y are both negative. Well, let's choose values of x and y. What we could have for part B is x equaling -1 and y equaling -2, say. What will we end up with? Well, the left hand side will equal -1 times -2 square rooted, which is equal to positive square root 2. And on the right hand side we have -1 plus -2 divided by 2, which is equal to -1/2. So what can we say here then? Well, we can conclude that as the square root of 2 is greater than the -1/2, the result is not always true. Question number 12. A student was asked to give the exact solution to the equation 2 to the power of 2x plus 4 minus 9 lots of 2 to the power of x equals 0, and the student attempt is shown below. We have to find 2 errors made by the student. Well, we've got the line over here, which is what the question is, and then let's see what we've got here for the second line. We've got 2 to the power of 2x plus 2 to the power of 4. Well, straight away this is wrong, because we need to use the rule a to the power of m plus n is the same as a to the power of m times by a to the power of n. They've added instead of multiplied. So one mistake that was made. Line 2 should be 2 to the power of 2x times 2 to the power of 4. Let's continue anyway. If we let y equal 2 to the power of x equal y, then we've got y squared minus 9y plus 8. Well, 2 to the power of 4 is certainly not 8. That's equal to 16. So we've got an error over here. And that error is line 4 should be 2 to the power of 4 equals 16. And now we have to find the exact solution to the equation. So for part B, I've got 2 to the power of 2x plus 4 minus 9 lots of 2 to the power of x equals 0. And if I split this up, I should have 2 to the power of x times by 2 to the power of 4 minus 9 lots of 2 to the power of x equals 0. So I've got 16, which is 2 to the power of 4, lots of 2 to the power of 2x. Well, this I'm going to rewrite as 2 to the power of x squared. When I multiply the powers, when I've got a base to a power to another power, I multiply the powers. That's where the 2x comes from. And then I've got minus 9 lots of 2 to the power of x. This is all equal to 0. So now what I will do is I will let y equal 2 to the power of x. And if I do that, I've got 16y squared minus 9y equals 0. If I factorize, I've got y lots of 16y minus 9 equals 0. So y is equal to 0, or y is equal to 9 over 16. Now, as 2 to the power of x cannot equal 0, y equals 0 is not a solution, and so we have 2 to the power of x equals 9 over 16 only. And if I solve this, we have x equals log base 2 of 9 over 16 being the only solution. Question number 13, we have to factorize completely x cubed plus 10x squared plus 25x. For part A, we begin with x cubed plus 10x squared plus 25x. And what this is equivalent to, if I factorize out an x, we've got x lots of x squared plus 10x plus 25. And x squared plus 10x plus 25 can be written as a perfect square. We've got x lots of x plus 5 all squared. Now for part B, we have to sketch the curve y equals x cubed plus 10x squared plus 25x, showing the coordinates of the points at which the curve cuts or touches the x-axis. Well, where it would touch the x-axis, we can find that out by setting y equal to 0. So we've got 0 equals x lots of x plus 5 all squared, from which we can see x is either equal to 0 or minus 5. And this minus 5 would correspond to a repeated root. So let's sketch the graph. Here is a sketch of the graph. We've got the root over here at minus 5 and 0. And 0 is also where it crosses the y-axis. Hence we've got the graph of y equals f of x, where f of x is y cubed plus 10x squared plus 25x. Now for part C of the question, the point with coordinates minus 3, 0 lies on the curve with equation y equals x plus a all cubed plus 10 lots of x plus a all squared plus 25 lots of x plus a, where a is a constant, and we have to find the two possible values of a. Well, if I call this equation 1, and if I call this equation 2, and we'll call this equation 3, what you can see is to go from here to here, we have a translation by vector minus a0. So let's write that down. We have a translation by vector minus a0. And so what we're going to do is rewrite equation 3. And so equation 3 becomes y equals x plus a lots of x plus a plus 5 all squared. Now, if I consider this point minus 3, 0, I can use this coordinate to find the value of a. I have 0 equals minus 3 plus a multiplied by minus 3 plus a plus 5 all squared. So I've got 0 equals a minus 3 lots of a plus 2, from which I can conclude a is either equal to 3 or minus 2. We've got the two possible values of a. Question number 14. A town's population P is modelled by the equation P equals AB to the power of T, where A and B are constants and T is the number of years since the population was first recorded. The line L shown in figure 2 illustrates the linear relationship between T and log base 10 of P for the population over a period of 100 years. The line meets the vertical axis at 0,5, as we see here, and the gradient of L is 1 over 200. For part A, we have to write down an equation for L. So for part A of the question, this will be similar to y equals mx plus c because we've got a straight line. But instead of us having a y and an x, we've got a log base 10 of p, and we've got a t. Now the gradient we know is 1 over 200. So we've got log base 10 of p equals 1 over 200 t, and we know that the intercept is 0, 5, so we add on 5. This is the equation of the line L. Now for part B of the question, we have to find the values of a and b. Now, we've got the equation p equals ab to the power of t. So if I replace the p with ab to the power of t, I have log base 10 of ab to the power of t equals 1 over 200 t plus 5. And if I use the addition law on the left hand side, I've got log base 10 of a plus log base 10 of b to the power of t equals 1 over 200 t plus 5. Now, when comparing, you can see log base 10 of a is equal to positive 5, and the reason for that is they are constant terms. Well, before we do that, perhaps it will make more sense if I use the power law. I've got log base 10 of a plus t log base 10 of b equals 1 over 200 t plus 5. And now you can compare the constant terms. You can also compare the t terms. And so, if we have log base 10 of a equaling 5, a will equal 10 to the power of 5. And if we compare the t terms, we have log base 10 of b equals 1 over 200, so therefore b is equal to 10 to the power of 1 over 200. For the first part of part C and then for the second part, we have to, with reference to the model, interpret the value of a and b. Well, a would represent the initial population. A would represent the initial population, and b would represent the proportional increase of the population each year. Now for part D, we have to find the population predicted by the model when t equals 100 to the nearest 100,000, and then the number of years it takes for the population to reach 200,000 according to the model. So, for part D, we know what p is. P equals ab to the power of t. Now we know what a is. That's 10 to the power of 5. I know what b is. That's 10 to the power of 1 over 200. And then I'm going to raise this to the power of t. Now, when t equals 100, I've got p equals 10 to the power of 5, lots of 10 to the power of 1 over 200 to the power of 100. And so if I work this out, we've got 10 to the power of 5 times by 10 to the power of 100 over 200. It turns out we get 316,227.7, etc. And so we can conclude from here then, the population is 300,000 to the nearest 1,000. And now, the number of years it takes for the population to reach 200,000, well, for this, we are looking at p equaling 200,000. So we have 200,000 equals 10 to the power of 5 times by 10 to the power of t over 200. So if I rearrange, 10 to the power of t over 200 will equal 200,000 over 10 to the power of 5, which is 2. So t over 200 will equal log base 10 of 2. So t equals 200 times by log base 10 of 2. So if I work this out, 200 times log base 10 of 2, we get 60.2 years. And this is given to 3 significant figures. Now, for part A, we have to state 2 reasons why this may not be a realistic population model. Well, for our first reason, the model predicts unlimited growth, and for the second reason, the population growth may not be proportional to the population size. Question number 15. We've got the curve C1, which is shown here, and this has equation y equals 4x squared minus 6x plus 4. We've got the point P with coordinates 1, half, 2, which lies on C1, and the curve C2, also shown in figure 3, it's got equation y equals 1 half x plus the natural log of 2x. The normal to C1 at the point P meets C2 at the point Q, and what we have to do is find the exact coordinates of Q. Well, let's draw a diagram to illustrate what's going on. Here is a diagram which illustrates what we know so far. We've got the tangent to C1 at the point P, and then we've got the normal to C1 at P, and the normal intersects C2 at the point Q. We need to find out the coordinates of Q. Now, before we do anything else, we need to find out the gradient of the tangent and use that information to find the gradient of the normal, and then we can find out the equation of the normal and find out where that equation intersects C2. So, to begin with, let's find out what dy over dx is. dy over dx is equal to 8x minus 6, and at the point P with coordinates 1 half, 2, the value of dy over dx will equal 8 lots of 1 half minus 6, which is equal to minus 2. What does this represent? Well, this would represent the gradient of the tangent. And so, what we can conclude from here then is the gradient of the normal is 1 half. So, the equation of the normal using the point P, we have y minus 2 equals 1 half lots of x minus 1 half, from which we can conclude, well, this is the same as y equals 1 half x plus 7 over 4. So this is the equation of the normal. Now I'm looking at where the equation of the normal, which is the result here, intersects C2. Now we know the equation of C2, so if I set those equal to each other, I've got 1 half x plus 7 over 4 equals 1 half x plus the natural log of 2x. So if I tidy this up even further, well, you'd recognise the 1 half x's cancel on both sides. So I have 7 over 4 equals the natural log of 2x. If I anti-log both sides, I have 2x equals e to the power of 7 over 4, from which we can conclude the exact x coordinate of q will equal 1 half e to the 7 over 4. So when x equals 1 half e to the 7 over 4, I can find the corresponding y coordinate. We've got y equals 1/2 lots of 1/2 e to the 7/4 plus 7/4. And it turns out this is the same as 1/4 e to the 7/4 plus 7/4. And so the coordinates of Q will be 1/2 e to the 7/4, 1/4 e to the 7/4 plus 7/4. This is the coordinates of Q. Question number 16. Figure 4 shows the plan view of a design for a swimming pool. The shape of this pool ABCDA consists of a rectangular section ABDE joined to a semicircular section BCD, as we see in figure 4. We're given that AE is 2x and ED is y meters, and the area of the pool is 250 meters squared. We have to show that the perimeter P meters of the pool is given by P equals 2x plus 250 over x plus pi x over 2. So to find the area, I have the area of the rectangle, which is 2x times by y. Then I've got the area of the semicircle, 1/2 pi r squared, and this is equal to 250. So I've got 2xy plus 1/2 pi. Now r over here will equal x. If AE is 2x, half of that will be x. So the radius is x. So I add on 1/2 pi x squared. The result of this is 250. And so therefore, y will equal 250 minus 1/2 pi x squared divided by 2x. Now, for the perimeter P, we've got 2y plus 2x, so that will be this length, and this length, and then we've got half of the circumference, so that will be 1/2 pi times by 2x, where the 2x is the diameter. And so we've got 2y plus 2x plus, well, here we've got pi x. A half times by 2 gives the 1. Now I know what y is, I've already worked that out. So I've got two lots of y, which is the result here. And then I will add on to this 2x and then pi x. So if I multiply through by 2, we've got 500 minus pi x squared over 2x plus 2x plus pi x. And so if I split this up, we've got 500 over 2x, which is 250 over x. And then we have minus pi x over 2 plus 2x plus pi x. And so therefore we can conclude P is equal to 2x plus 250 over x. And then we've got minus a half pi x plus pi x, so that will be positive pi x over 2. So that's what we wanted to show that the perimeter was, and now we have to explain why x is in between 0 and 500 over pi square rooted. So for us to do this, what do we know so far about distance? Well, distance is positive, which implies x and y are both positive. And if that's the case, because the distance must be positive, this entire result, okay, which, by the way, we know is the same as, well, actually, if we think about what y is, which is this result, this also must be greater than 0 because we know that x and y are both greater than 0. So we've got 250 minus a half pi x squared over 2x being greater than 0. So 250 minus a half pi x squared is greater than 0. Multiply through by 2 and rearrange. We've got 500 minus pi times by x squared is greater than 0. So for our critical values, we've got x equals plus minus 500 over pi square rooted. And because we know x is greater than 0, we can conclude 0 is less than x, which is less than 500 over pi, and then this is square rooted. We take the positive version because distance is positive. Now for part C, we have to find the maximum perimeter of the pool giving answer to 3 significant figures. Now the word maximum suggests to us we would have to differentiate and set the derivative equal to 0. Now we know what p is. P is this result here. So what we're going to do for part C is begin with this, and then if I rewrite this such that we've got 250 x to the minus 1, that makes the differentiation easier for us. And then we've got the pi over 2x. So when I come to work out what dp over dx is, I've got 2 minus 250 x to the minus 2 plus pi over 2. And I need to set this equal to 0. So I have 2 minus 250 x to the minus 2, which I'm going to rewrite as 250 over x squared, and then I'm going to add on pi over 2, and this is all equal to 0. Now if I attempt to solve for x will equal 250 divided by 2 plus pi over 2 square rooted. And what's crucial here is we're taking the positive square root because x is greater than 0, and if I work out the decimal equivalent of this, 250 over 2 plus pi over 2, it turns out we get 8.367. So the maximum perimeter, well, we just have to substitute back in. So therefore p max is equal to 2x, so that's 2 lots of 8.3 etc. plus 250 lots of 8.3 etc. to the minus 1 plus pi over 2 lots of 8.3 etc. And if I work this out to 3 significant figures, 2 lots of this plus 250 lots of this to the power of minus 1 plus 0.5 pi lots of this, it turns out we get 59.8. So we have 59.8 meters squared, rather meters, to 3 significant figures. Question number 17. A circle C with centre minus 2, 6 passes through the point 10, 11. For part A, we have to show that it also passes through the point 10, 1. Now what we'll do to begin with is we'll actually find out the equation of the circle. For that we need to find out the radius. The radius will equal 10 minus 2 squared plus 11 minus 6 squared square rooted. And if we work this out, 12 squared plus 5 squared square rooted is 13. The radius is 13, and so for the equation of the circle, we've got x plus 2 all squared plus y minus 6 all squared equals 13 squared. Now if I substitute the point 10, 1 into the left hand side would equal 10 plus 2 all squared plus 1 minus 6 all squared, which is 169, which does indeed equal 13 squared. Perhaps if I write that down, the right hand side is 13 squared, which is 169, and because those are equal, we can conclude that 10, 1 lies on the circle. And now for part B, the tangent to the circle at the point 10, 11 meets the y-axis at the point P, and the tangent to the circle at the point 10, 1 meets the y-axis at the point Q. We have to show that the distance PQ is 58, explaining clearly our method. Here is a diagram, and we've got the line here and the line here, which are tangents at this point and this point respectively. We've also got the centre minus 2, 6. We want to find the distance PQ. Now P is over here, Q is over here. We need to find out the coordinates of those first, which will allow us to find the distance. Now what we'll do, we'll find out the radius of the tangent at this point, and we'll also find out the radius of the tangent at this point. So we need to find out the gradient of the, we need to find out the gradient of the tangents of this line and this line. So let's consider the point 10, 11. The gradient of the radius will equal 11 minus 6 over 10 minus 2, which is 5 over 12. So that's the gradient of the radius. So the gradient of the tangent is equal to minus 12 over 5. And if it passes through this point here, we can therefore conclude that the line has equation y minus 11 equals minus 12 over 5 lots of x minus 10. So this equation will belong over here. That's this line here. And what we can now do is see what happens when x is equal to 0. So we've got y minus 11 equals minus 12 over 5 lots of 0 minus 10. So what we can conclude over here then, if I solve for y, we've got minus 24 plus 11, which is 35. So y will equal 35, and so the coordinates of P will be 0, 35. So we've got 0 across, 35 up. we can do a similar thing with this tangent here. So if I consider the point 10, 11, the gradient of the radius is equal to 1 minus 6 divided by 10 minus 2, which is equal to minus 5 over 12. So the radius, rather the gradient of the tangent then, is equal to 12 divided by 5. So that's a negative reciprocal. And so the equation of the line, that will be given by y minus 1 equals 12 over 5. Rather, here we've got this point here. Lots of x minus 10. And if I solve for y is equal to, well, we've got minus 24 plus 1, so that's minus 23. And so q has coordinate 0, minus 23. So we've got 0, minus 23. And so therefore PQ will be the total distance. So for the total distance, I want this distance here. So that distance is going to equal 35 plus 26, because this distance is 26, rather, plus 23, because this is 23 units below the x-axis. And so therefore PQ is equal to 35 plus 23, which is equal to 58. And that's exactly what I wanted to show.